Welcome everyone to this webinar entitled Edge2Web for AWS IoT Sitewise. I'm your host, Fred Holohan, and in the next hour, we'll identify key digital industrial transformation challenges, introduce AWS IoT and Edge2Web, and demonstrate how Edge2Web for AWS IoT can be used in a connected factory application. First, a few housekeeping items. The webinar is being recorded for your future reference. You'll receive an email in the next few days that will direct you to the webinar video recording, presentation slides, and written Q&A. If you have questions, please type them into the Q&A box. We'll answer as many as we have time to cover live, and we'll also answer all questions in the written Q&A section that accompanies the recorded webinar content. With those items out of the way, let's get started. In addition to myself, I'd like to welcome Dave Thielett and Eddie Budgeon to the speaker panel. Dave is a key member of the IoT Partner Development Team at AWS. He spent the last decade developing IoT initiatives for a wide variety of business-critical use cases in maritime, building utilization, food processing, and others. Dave has built collaborative partner ecosystems around digital transformation for Fortune 2000 customers. He currently leads global initiatives in discrete manufacturing and agriculture, working with AWS partners and leveraging AWS IoT services to deliver innovations in asset optimization, product quality improvement, energy management, sustainability, and more. Eddie leverages over 25 years of experience in software delivery to help Edge2Web customers and partners succeed in creating high-value applications using Edge2Web products. He is well known to many of you in the audience as a knowledgeable, hands-on leader in the industrial IoT community. We're going to break the webinar into three parts. First, Dave will bring us through AWS's digital transformation perspective, particularly as it applies to industrial applications. I'll then introduce you to Edge2Web, our products, our integration with AWS IoT services portfolio, and finally, Eddie will demonstrate Edge2Web and AWS IoT in action using a connected factory application that was built in a few days. With those introductions finished, I'll invite Dave to start us off with an overview of Amazon for Industrial. Let's get started. Dave?
Thank you, Fred, and I really appreciate the opportunity to join with the Edge2Web team today. I'm looking forward to speaking with all of you, and I'm really excited about the demo that they're going to show. As we get into things, I'd like to start maybe by sharing some thoughts on how AWS approaches industrial use cases and IoT services in general. These are a few of the industries that we're using technologies like cloud computing, IoT, and advanced analytics to improve productivity and lower costs. But our definition of industrial is broad and includes manufacturing-related activities and other verticals such as CPG, life sciences, automotive, aero, and construction. We see customers improving productivity with faster times to market for new products, creating new revenue streams, improved service capabilities. We also see them lowering costs by reducing water, air, gas, electricity, and steam consumption, improving throughput, and reducing things like machine unplanned downtime. We'll talk a little bit more about some of the use cases on future slides. When our customers try to realize the improvements for productivity or the cost reductions, we usually see some common challenges that emerge. Security in the lower right is often top of mind for every customer, and making sure any IoT infrastructure can securely work either on-prem or in the cloud is a critical first task for any deployment. But in addition to this, we also see things like basic data access as a huge challenge. Manufacturing facilities are snowflakes, and even within the same organization, there can be tremendous diversity in equipment, systems, personnel, and processes as they've merged and acquired new plants or divested things over the years. Another challenge we see is the management of that data with abundant unstructured streams of data coming in and knowing what to do and how to contextualize this. Scale, again, that's a huge one that we see as a problem. 80% of pilots fail to scale, and the typical causes of this are sometimes technical, but often it's about the organizational change to embrace digital and the people and processes that also go along with this technology, all of which must be aligned throughout the organization. The last challenge our customers see is having the right data at the right time to the right people and the different automation systems required to act on those insights. Understanding the use case needs is critical to architecting an appropriate solution, but customers also realize that a true digital transformation is more than just a collection of individual point solutions. We'll get into some of the different types of use cases that customers derive business value from on the next slide, but I think it's important to understand that notions of the edge and cloud are blurring. This sort of flexible edge has started to refer to things at the machine level, PLC level, site level, and even the cloud level activities as we seek to optimize the use of compute and data resources against the cost and time to service factors. Often this is driven by the use case needs that customers have, but also must be done in a way to avoid the current situation, which is a hodgepodge of point solutions that have grown up over the years. The other key is the introduction of things like AI and ML processes to industrial data. The minute you start to move beyond a machine or two, the amount of data becomes so unwieldy that you really do need things like AI and ML tools, either at the edge or in the cloud, to process and analyze, especially as you pull OT data off the shop floor and integrate it with IT data like production schedules or product quality information. Let's talk about a few of the use cases on the next slide. So just as our definition of industrial is broad, we see a broad range of use cases within our industrial customers. We see a ton of opportunities in Industry 4.0 initiatives around IoT for things like product and asset optimization, quality management, energy and sustainability is a big one too. And these go well beyond the factory itself and into things like the supply chain, worker safety with COVID, and also just basic accident prevention, all have a vein for IoT as an enabling technology within that solution. AWS focuses on foundational services to commoditize things like the plumbing for IoT for these different use cases. And our focus has really been on liberating data from equipment and PLCs, making that data available at the edge and cloud for processing. We then see a tremendous amount of solution specialization and verticalization, often through our partners like Edge2Web, that allow us to be both broad in covering all of these different use cases and deep. Take product quality, for example. A vision-based product quality solution in a welding station for an automotive OEM is going to look very different from a vision-based product quality solution at a protein food processing plant. Our customers want a firm foundation for their data lake that will allow them to address their specific use cases, and then to have ready-made solutions that solve for business outcomes for them. I mentioned earlier about the challenges of working with industrial data and complexity being a barrier to solution development. And I think as we try to simplify this, it's important to think about the few different levels that we've got going on here. At the bottom of the slide, you've got the actual physical assets and systems that are in place on the shop floor. And the information that's from them has to be translated from a physical world situation into something digital. That's sort of the first layer of the tech stack that you have to consider. And how do you then collect that information? Next is storing the information in a data platform that will allow you to work with it, contextualize it with other systems and machine data sets. Once you do that, and you'll see in the middle of the stack there, is the analytics layer that allows various tools for customers to develop or partners like Edge2Web to work with that data on specific business outcomes. And then last, I alluded to this earlier, it's the most important aspect is the act stage that sits on top. Knowing is really only half the battle, and the organization needs to have the people and processes ready to make changes based on the information, insight, and analysis that's coming out of these tools. At AWS, we know our customers are at various stages of what this digital transformation journey looks like, and they all have different processes and often different ways that they want to address how they go on that journey. And so to allow that flexibility, we take multiple approaches in working with customers. Of course, AWS was founded as a builder-to-builder kind of company, and some customers really want to leverage their own in-house resources to build their solutions and work directly with AWS. However, my experience in the industrial space is that most of these customers are not builders in that sense. They're more looking to purchase solutions that are ready-made. And this can be due to a variety of reasons, whether it's a lack of internal resources in terms of skill set or a desire only to focus on core competencies. But we see that most of the customers typically will want to buy that solution that can quickly show business value with their internal stakeholders. And they work with partners of AWS like Edge2Web to bring that skill set that Edge2Web possesses for their solutions around the industry and domain knowledge, as well as their deep skill sets with AWS in order to really create something and deliver for the customer on that business value continuum. With these ready-made solutions, there's often things like starter bundles that help quickly to understand value on their own equipment and then realize that value as they drive that organizational change. Well, that's what we're going to get into now, which is really exciting, and some of the things that Edge2Web has done. So I'm going to hand it back over to the Edge2Web team.
Oh, thank you very much, Dave. I'm going to be brief in my comments because I want to move the discussion to Eddie for the Edge2Web AWS Connected Factory demo. I think that's where things will become real for all of us. But let's do a little bit of an intro on the Edge2Web side so that everyone on the call has that context. Edge2Web is a SaaS-based software company that was recently ranked among the top 5 startups in industrial IoT, and that's out of 433 startups that were evaluated. We deliver low-code IoT development tools and runtime services that are targeted at the unique needs of industrial users. We also provide a growing portfolio of pre-built application components that make it super fast to implement new digital apps for OEE, asset performance monitoring, fleet management, and many others. We're going to see a couple of those components in action during the demo. Our products are designed to run on top of leading IIoT platforms and today support both AWS IoT and Siemens MindSphere. Our mission is to provide products that enable customers and partners to build innovative digital applications using AWS IoT and MindSphere without requiring app builders and industrial domain experts to master all of the complexity of those platforms. So when you think of Edge2Web, think power, simplicity, and speed. This slide provides a 10,000-foot view of industrial IoT. On the left side of the slide, we're depicting a factory, but it could just as easily be a wind farm, a water utility, a power plant, or one of many other industrial organizations. Although asset and process data has historically been siloed in the OT infrastructure, industrial companies are increasingly replicating it to leading cloud platforms like AWS IoT. Many digital initiatives begin with analytics and dashboarding, but digital leaders understand that most organizations need to integrate newly democratized factory data throughout their organizations and ecosystems. Thus, in addition to powerful services like AWS IoT, digital leaders require high productivity tools to rapidly build and deploy a wide range of custom applications that can improve their businesses in fundamental ways. Edge2Web products run natively on AWS and integrate with AWS IoT and the broader AWS platform of services. Applications built in Edge2Web for AWS are scalable from small work groups to global enterprises, and they're secured using AWS best practices. Our mission is to give your app builders access to all of the power of AWS, again, without requiring them to master all of the platform's complexity. Edge2Web products allow industrial domain experts and application developers to rapidly build, deploy, and operate a wide range of industrial IoT applications. Our products are used today by customers and partners to create apps for a wide range of connected factory use cases, as well as by machine builders who want to deliver new high-value digital services along with their hardware. Edge2Web currently offers 2 commercial products. Edge2Web Director is used to rapidly build user-facing applications that visualize data using over 30 different industrial renderers, highlight critical operating conditions, and guide users to take context-driven actions. Director easily integrates and displays complex plant asset hierarchies, fleet data, analytic outputs, for example, OEE KPIs, as we're going to see shortly, event data, and more. Director makes it super easy to create apps that give users multi-level drill downs, provide full read-write update capabilities to the underlying platform, and display data using spatial coordinates. Edge2Web Flow Server is used to perform complex server-side orchestrations such as plant systems integration, execution of analytics and machine learning services, and continuous systems monitoring. Flow server applications typically run on defined schedules, for example, once every 10 seconds or even once per second if needed, and perform compute-intensive number crunching, systems integration, and are used to notify key stakeholders when machines and processes are executing outside of their normal thresholds. In addition to Director and Flow Server, Edge2Web provides a growing portfolio of application accelerators. These powerful components provide pre-built functionality that's common to many industrial applications, including functionality to browse asset hierarchies, implement custom shift patterns, detect out-of-band operating events, and notify support teams before small problems become big problems. We provide these app accelerators at no charge with royalty-free distribution rights with full source elements so you can easily customize them to fit your needs. This diagram shows Edge2Web on AWS at a high level. Our two commercial products, Director and Flow Server, are supported by lower-level services for security, connectivity, and data orchestration. And as mentioned, we also provide a library of Edge2Web application accelerators that offer out-of-the-box functionality needed by many digital industrial applications. Edge2Web is integrated natively with numerous AWS IoT and surrounding services to give developers a single productive experience for creating advanced digital industrial apps. And unlike other IoT approaches, where you have to master one tool for user-facing applications and a different tool or environment for server-side processing, Edge2Web provides a learn once, use everywhere development model. A breakthrough benefit of industrial IoT is data and service integration. New digital apps must orchestrate diverse data and services into coherent insights and increasingly provide instructions for plant users. They must allow plant operators and supervisors to add human context, for example, a reason for machine downtime or an update to a scrap counter, a change to an OEE threshold. Those are things that need to be done interactively to improve the quality of information that drives better, smarter, more agile production decisions. To enable new context-driven applications, Edge2Web integrates with the full constellation of AWS IoT services, as well as a number of other supporting services from AWS and Amazon. Edge2Web provides built-in connectivity to all platform services required by industrial use cases like predictive maintenance, flexible OEE tracking, asset performance monitoring, fleet management, remote diagnostics, mobile field service, and many others. So this is the last slide before we get into the demo, and the goal of this slide is to provide a reference model that identifies common connected factory technology tiers, and the slide is aimed at helping you understand where Edge2Web fits relative to AWS IoT and other plant systems. Most manufacturers have implemented core technologies for automation, execution, ERP, LMS, and others. And although these technologies drive operational execution, they don't provide the performance insights across stations, lines, plants, and multi-site operations. And that's what we're going to get into now. Let's set the stage for our demo with a high-level picture. Manufacturers are driving to digitize assets and processes to derive important business outcomes, including reduced production costs through improvements in machine availability and performance, higher product quality, reduced scrap and rework, improved business agility and scale, and the digitization of domain expert knowledge, in other words, capturing their manufacturing tribal knowledge so it can be applied consistently and systematically. Our demo will focus mainly on providing operational and performance insights for a simple process-based use case, the batch production of latex paint. Having said that, the goals and concepts we're going to see in the demo can be readily applied to many different continuous and discrete manufacturing scenarios. This slide provides a roadmap for each iteration of our latex paint batch process. Water and paint concentrate are added to a reactor tank. The reactor tank then heats and mixes the fluids to create the finished product, which is then offloaded to a storage tank, and then the next batch cycle begins. After several batch cycles, the storage tank itself is partially drained to long-term storage. operating data such as temperature and tank levels are streamed into AWS IoT Sitewise using an Edge2Web data simulator. Edge2Web apps continuously monitor process variables in Sitewise to detect operating anomalies, compute OEE performance KPIs, and visualize data for users. This diagram gives more detail about what's going on under the hood with the demo. Edge2Web Flow Server, shown on the left part of the slide, is performing a couple of important tasks. The first one is continuously pushing simulated data into Sitewise via the AWS IoT Core service. And second, continuously reading stored data from Sitewise to compute OEE metrics. Edge2Web Director, shown on the right part of the slide, is also performing three important functions. The first is allowing plant supervisors to configure shift calendars and machine stop reason codes for their manufacturing sites. Second, querying Sitewise to retrieve and display OEE performance dashboards. And third, querying Sitewise to display operating data, OEE metrics, and event information on an operational insight dashboard. Let's see Edge2Web for AWS IoT in action.
Thanks, Fred. Let's jump right into the demo. As you can see, we've got a fairly rudimentary menu to begin with in the OEE stack. And I'm going to start with the OEE Solutions. We'll walk our way into the monitoring of maintenance data and performance data, and then take a brief look at the build. So the classic question that comes out from looking at any application in a demo is, show me the code. How can I take over and make this mine? This is something that you can provide your authorized users access to. There'll be a number of pages and panels that we'll walk through for different roles with different folks in your organization. If you've already started along the OEE and performance monitoring and management, you'll know that the OEE as a mathematical concept is actually pretty easy. However, there is configuration necessary to do it your way. So how folks describe what might be good output and bad output, how they might describe what the states are of particular machines that they're operating, have an enormous impact on the output and the OEE efficiency indicators themselves. So they get a lot of attention spent on them to actually set it up the way that you want it to as your individual operation, factory, even the smaller units of operation. Don't have to be company-wide. A different site could actually operate in a different way. You may have multiple product environments, and each one may have the whole set of OEE configurations. So I'll spend a brief moment describing a few of the core configurations that would be necessary to actually make an OEE solution work in your environment. So to do that, we've provided a set of very easy to use applications that would be used by a select group of folks who would be very knowledgeable about your industrial processes and how you operate your machine. I have actually 3 sites, and I'm defining the reason tree, so this definition of what's working, what's not working at a site level. It can in fact be pulled at various other levels, but we've seen through multiple projects, it's very often held at a single site level. But we are currently in other projects working with multi-site operations that have very different reason trees depending on where they are on the planet Earth and what they're currently carrying out. So these are simple to use technically, but they do require detail of your operation. You have specific colors that you may want to indicate various states if that's important to you. The states themselves are actually managed as a stop state, i.e. that's something that's either been reported or been input by a human that the machine is stopped. And do you need to justify certain states? So certain reported states may need further investigation. Again, a fairly simple tool to use, but a fundamentally important part for you to configure how you want your OEE environment to run. A similar one would be your shift, but how do you provide a shift management so that you are able to not only have your OEE KPI statistics related to time or related to time periods, a day or an hour, you can actually associate them with shifts, which is a different context of what is the efficiency of this shift versus another shift that may or may not be appropriate to your operations, but we've seen many that do have that. So once done with the configuration, you're going to want to move into a set of display panels that will show you the OEE of all the machines. So it's directed to a particular plant, and it's a supervisor or an area manager. It could be very useful to have this kind of dashboard that says, well, basically my operation seems to be working okay for the ones I care about. But the idea here is that you'd be able to choose another plant, choose time frames, choose your refresh interval, then be able to provide even the configuration at this level so that the area viewer would be able to choose what it is they want to see. Clearly, goal of this would be to indicate something of interest to drill down, which I'll now do. Again, a series of requests were sent from the Director application to the AWS services in the background to pull the data. And this page demonstrates the visualization of your data. These different elements could be shown a different way. You are absolutely enabled to customize how you might want to see the data. You'll notice I've got the same bars at the top, these utility bars. This is part of application accelerators, which are utility components that provide functionality that could be used in any kind of application. Similarly, do I want to view the screen in a different language? This is not going to affect the data, but you have the ability to build localized and multi-language applications on the page. As I mentioned, a set of displays for current values of what the actual current value is now. We have some trend information that will change the time frame, pull more data. You can see that it's actually operating on a refresh cycle where it actually refresh every X period, which I defined up here. It's unusual that you would do OEE at 30-second intervals. That's a very short perspective to be looking at OEE, but for demonstration purposes, left at 30, but typically 5 minutes, 10, whatever this you wish. You can mix this, even though this is OEE-oriented data. There's nothing to stop you mixing and matching the data to provide the most contextual output for your operation and for your operators. So I pulled some other data, reactor temperature in this case, over a time graph, which will allow you to do potentially some element of correlation between, oh, the states have changed and look, the temperature was too high, and things like that in a near real-time operation. This is an OEE application that Fred had mentioned as one of the application accelerators. I'm going to move across to the other side and to show a slightly more visual layout of operational data that you may be monitoring your machine. So if operational efficiency is one thing, this might just be the representation of the operational parameters that are important to somebody viewing the machine. As I had operational data in the OEE environment, you can have OEE data in the operating environment and then have links that allow you to jump between the two environments should you wish. Your choice whether you link these things for demo purposes, we did. As you can see, there's a number of visualizations, and there are 30 different outputs of data that you can provide to your users as you build and customize your applications. As you can see, tables, time series with thresholds. This is actually events being pulled from DynamoDB. And then the same data is being mapped onto the time series. So you can actually see where there are specific temperature alarms that are being recorded against my time series, which may be the cue for somebody to take an action in a near real-time environment. At the bottom, we've actually got the same brief overview of what's happening in a number of similar reactors. So although this dashboard was built once for a specific target for a type of reactor, if I collect the data or when I provide navigation for users for the similar reactors, then I can pull all of that together to show folks so that they can actually map between different assets just by simply selecting them, and they would jump to different data contexts for that. Now moving from the application user, a plant operator in this particular case, to the application builder and responding to the question, show me the code, let me navigate to the designer environment. As I'm an admin developer in the application, I have a direct link from the runtime page into the designer to open up the page in the designer environment. Designer provides a low-code service-oriented builder architecture that does not require the usual code compilation and deployment steps, and we'll see this a little further on. This will shorten the time and distance from building to deploying to runtime to a few seconds for any new application developments or fixes to existing componentry. We're now viewing the page in the page editor. A page is a unit of publishing in Director. It represents a unit of activity for the application user, as we've seen in the demonstration so far. Each page has one or more cells, and I'm clicking on the individual cells just to highlight them. These cells can contain screens for visualizing data, forms for user input, user controls for asset navigation, and the like. All cells can retrieve and manipulate data. It's also possible to have non-visual cells that do particularly heavy lifting on behalf of the page. Application builders have a great deal of control over sizing and positioning and display attributes of the cells and are able to adjust the layout of a particular page using custom controls to add columns, remove columns, so they can add additional componentry into an existing page, for example. Cells have their own inputs and potentially outputs, and they can exist independently on the page or have their inputs passed from other cells. A time range selector would be a good example that would generate output fields that could be used as input to other cells to drive things like a time series request or an events table retrieval. There's no limitation on a page retrieving from multiple data sources and/or different data services from the same platform, allowing you to integrate and operate on a mixed data and service results at the page level so that you can represent a higher level of value to the user. Cells can also make requests to the back-end platforms like AWS IoT at different intervals to improve the performance and scalability of the page. Now let's drill into one of the cells to look at the flow editor. The visual flow editor enables app builders to rapidly create advanced connected factory applications. It follows the usual concepts as in building any software application in defining your inputs and outputs, fetching, retrieving data, manipulating that data, and then displaying that data to your end users. You can consider a flow as a unit of work. It represents a process flow of action tasks called flow steps. Again, each flow step is considered a microservice and will receive its own inputs, carry out its own tasks, and then deliver its own outputs to the rest of the flow. The collection of flow steps is modeled with an auto layout diagramming to improve productivity and avoid complexity for the app builder. So to extend your existing flow, you can simply double-click on a line or use one of the toolbar icons to insert additional activities, and then choose from a list of activity types that you'd like to carry out in that particular place. For example, if I wanted to introduce a decision, I can simply place it into the existing flow, configure what the decision branching might be, and decide on the different branches that I may want to operate depending on the values of the return decision. Now let's look at some of the key flow steps within our demo flow. First of all, I'll focus on the retrieve data. Director provides a set of pre-built connectors for the platform services we support out of the box, including a number of AWS services used in the demo. For example, we use the AWS IoT site-wide service to query asset metadata and operating time series data. We also used application configuration files that were retrieved from S3 buckets to apply specific behaviors for our use case. The AWS IoT event service is used to direct triggered alarms to a DynamoDB store from which we query the DynamoDB service to retrieve historical events to display as an events table on the dashboards. We also use the AWS IoT event service to list open alarms and allow the operator to acknowledge current alarms. However, beyond the standard connectors provided, app builders can add their own connections for any REST-based service and interact with that service via the usual data service property options, or simply using a Postman-like interaction if they prefer. This allows an extensible connectivity strategy to bring other valuable data and information into your applications. Once added, custom or pre-built connectors behave in the same way. We provide you a list of the operations that are available from the service and an indication of the input and output data field structures for you to complete the call to the API service and to retrieve the data. You can also generate your own URL-based Postman-like requests to the service. Once retrieved from a data service into the output field, the flow simply regards the returned output as data. It is completely disassociated from the actual connection service itself, while maintaining, obviously, the data structure that was returned. This allows you to then carry out any further manipulation or integration between different data sources or data services, as in the case of our demo, using multiple AWS IoT services to create the various output renderers that we saw on the dashboard. Let's look at another key activity type in the flow. We'll focus on an assign statement. For data manipulation, the only programming language skill necessary in Director is JavaScript, one of the most common industry standard languages for handling web-based data. Besides an extensive set of industry standard and Edge2Web specific JavaScript libraries, app builders can build or add their own JavaScript libraries to provide additional functionality for application-specific use cases. This could be custom algorithms for data manipulations, a detailed analytical routine, or something as simple as a commonly used data transformation. So you can extend that data handling capabilities to suit your specific needs and provide high productive skip libraries for your power users to leverage for their own applications. Now let's look at how the data is displayed. Either in a screen step or an end step, data and other visualizations are created using the direct-to-screen editor. This is a WYSIWYG editor with UX controls that are familiar to any user of PowerPoint and Word. In our demo, we created a table because we wanted to display the React and storage tank data side by side. After creating and stylizing our table, a small example here of changing color, for example, you can drop fields into the table from a special drop-down list of all of the fields that are available in your flow. Once the field has been positioned, we can select the preferred data renderer to use for visualization. Director has a choice of over 30 different renderers covering a wide variety of industrial use cases. They cover graph displays, input controls, list, tree, and table layouts. Of particular note are the flex list renderers. These allow you to handle complex lists of data and to present each set of data with the same visual card layout, or to pass the data set to a separate flow and have it processed in an even more custom manner. The primary layouts for flex lists are a grid matrix, a geomapping service, if you have GPS coordinates, a spatial layout where you can actually lay the assets and the time series graphs onto a picture of your environment or your asset, and a tab-based layout. This allows for high productivity in designing applications for fleets of assets with their own data. For this screen, we chose a text renderer for the table header fields, and within the table, liquid gauges to represent the levels of the specific tanks. Each data render has numerous display options. These can be overridden specifically for this particular case, or data-driven at runtime if a more dynamic presentation style is required. Default values are set on the page using a theme, which is a configurable collection of all display options that you can adjust and create custom themes for branding or specific presentation needs. Let me cancel all the demo changes I made so that we can run this flow in isolation. During the app building phase, you can test run your code directly, even if not complete, to see how the flow operates to a certain point or screen in your flow. There's no need for any compilation or deployment task at any stage. So let's run this flow as is. It's already been supplied with some sample data that will allow it to run, and it generates the exact request that it will do in runtime and displays the data in a full screen mode in this case, because it's not actually displaying on the page. We provide a log view that will allow you to trace the individual steps of your flow that are executed, including finding any decision paths or parallelism that you may have. Where you're interacting with API services, we'll be able to see the exact input and the outputs generated from the direct calls to the backend environment. You can also see the value of the data fields at the point of the flow. In this case, the flow is completed, but this will show you all of the data fields and their values that are present. You can also expand if there are nested, more complex data types. And if you select any field, you can copy the contents and place it somewhere else. We allow you to store the data of any particular run as sample data, which will allow you to both execute the flow and also review your data as you go through the testing process. Once you've completed testing, it's a simple task for deploying to runtime. I've now returned to the main designer homepage where a list of all of the cards of all of the artifacts in the application are homed. You can describe them into different projects, and you can apply any filtering that you wish and then sorting of flows you may want to see, so you can actually manage a large set of artifacts should you have them. Although in this demo, we introduce you to the visual app builder tools for Edge2Web Director, it's worth noting that you use exactly the same AWS IoT connections, the same flow editor to build your Edge2Web flow server flows. Flow server also includes a task scheduler that allows you to find when each server-side app will execute, and this can be as frequently as a second or a minute or an hour, or you can set a specific cron expression to allow that to happen. So returning to the runtime view, this concludes the demonstration part of the webinar. And to quickly review what we've seen, From an end user perspective, where I've returned, examples of OEE and asset monitoring applications built in Edge2Web using the AWS platform services. We've seen a few of the Edge2Web application accelerators that provide out-of-the-box functionality for configuring and running the apps we've demoed. And from an app builder perspective, a brief intro into the Edge2Web tools that we use to create the runtime demo components and can be used to build any application using the AWS IoT platform. So in wrapping up the demonstration, I'll now hand back to you, Fred.
Fantastic. Yes, so we do have some questions. Let's just get into them. Dave, I think this first one is for you. How are you seeing customers approaching data at the edge and in the cloud?
Yeah, it's a good question. And we're really seeing customers approach it in a hybrid sort of way. So if you think about the example I gave earlier around product quality, you go into an OEM or in the auto industry or something like that, no one is going to send images of their product quality to the cloud. They're going to want to process that on the edge. And that's for both security reasons and also because the use case demand of a throughput has a time constraint on how fast that has to be processed, and the round trip up to the cloud for processing and back down just doesn't make sense. So you're going to see that being at the edge. Similarly, you see a lot of things at the edge when there's high velocity of data to help maintain cost control over their spend. What we're really seeing is it varies from use case to use case. And even saying the edge can mean at the equipment level, the PLC, the factory shop floor. What does that edge mean can be different things for different use cases. But we're seeing that hybrid approach where things that need to be done in real time or very near real time happening at the edge, while other things, historical analytics and trend analysis, can happen in the cloud with aggregated data.
I think we've got time for one more, so I'm going to pick one for Eddie. Can the OEE app you showed handle a manual site or a hybrid site where all or some of the equipment is not yet automated and the raw data is prepared and entered by the operating staff?
Yes, and that's a very common physical situation in the real world. Very few people have got everything finished from one side or the other. The answer is absolutely yes. The way that we approach a project like that is that there are elements of the data input that can be absolutely managed via either spreadsheets sent in every shift, every hour, every day. Once the data is arriving in whatever frequency and volume, it doesn't matter how much data you want to push, then the same kind of dashboard you're looking at here would come into effect. Slightly different than this. This is kind of moving. It's very unlikely that a manual OEE dashboard would do that. But yes, we have fully automated sites, hybrid sites, and then manual sites where all of the data input is actually being done via spreadsheet or by forms like the ones I was filling in earlier on. So the answer is yes.
Thank you very much. We are tight on time. There are other questions that we're not going to have a chance to get to. Again, I'll just remind you that post-webinar, we'll put together the recording, a PDF of the slides we went through, and the full written Q&A for the questions you all have asked that we have not gotten to. So thank you very much all for coming and taking the time to learn a little bit. I'd like to especially thank Dave Thielert for joining us and telling us the industrial story from the Amazon point of view. And hopefully we'll have an opportunity to work with all of you in the coming weeks and months. And of course, feel free to call on us at any time. Thank you very much. And with that, the webinar is over.